Welcome to the Forest Analytics Landing Podcast. I'm your host, Matt Russell. In this podcast, we'll talk about how data and analytics are transforming the forest products industry. We'll share how a research-based approach to analytics can empower your forestry organization to make better decisions with your data. Well, hello, everyone. Welcome to today's podcast. Today I want to talk about a really traditional aspect of forest measurements, and that's how do we convert the volume of a tree to weight. And weight can be either the biomass of the tree or what we're very interested in nowadays is the carbon. So how do we go from traditional measurements that foresters collect in the field, from DBH, diameter breast height, to the total height of a tree? How do we then estimate volume? And then how do we convert those measurements or those estimates of volume into biomass and carbon? And so, as I mentioned, this has kind of been a long-standing issue that foresters have been faced with. If you look at the way that we do forest inventory, it's very similar across regions. You know, boots on the ground forest inventory, whether it's permanent sample plots or whether it's or fixed radius plots or some kind of prism sampling with variable radius plots. It's pretty similar. You know, they're measuring things like species, height, and diameter at a basic kind of a core inventory. But that's not always what we're interested in doing. I had one forest mensuration professor when I was in graduate school that basically said, you know, if we want to be selling what we have in the woods as, say, toilet paper, well, we ought to measure trees in terms of how much toilet paper they have and that are contained in them instead of how much volume is contained in them. Because we often have to convert between all these different measurements in forestry, whether it be from inches to volume, to basal area, to biomass, and things like that. And so the ability for us to transition between these different scales of measurements is something that foresters deal with on a daily basis. And so if you look at taking those basic forest inventory measurements like diameter and height, foresters then often calculate the volume. And now the volume of the tree is obviously could be either cords, kind of when it's scaled on a per acre basis, or it could be the board feet. And so depending on the region, depending on the merchantability, whether they're saw logs in a forest or whether it's pulpwood, it's going to depend on how you determine the volume of a tree. And so there are a ton of equations and models for estimating the volume of trees. There are different ways to measure the volume and to estimate the volume. There's different log rules. There's so many different equations. I got looking into how the U.S. Forest Service deals with this, and they have a national volume estimator library that has literally thousands of equations for estimating tree volume for U.S. species. And if you look at that, it's literally megabytes in size, those data files that contain all of those different parameters and coefficients to estimating the volume of trees. And so now we often do forest inventories because we're interested in how much carbon is found in the forest. And so we've not changed how we inventory forests with boots on the ground, but we're interested in understanding some of the attributes of carbon that are in the forest. And not just, forest inventories have traditionally been focused on estimating the above ground biomass and really what's in the stem, because the stem is the merchantable piece that much of our forestry literature and growth and yield information is based on. And so with carbon, we're interested in a lot more than just the stem of the tree. We're interested in the total above ground biomass, what's below ground, other pools like the forest floor and litter and soils, and some of those we just don't get by understanding how much volume is in the tree alone. And so I was really interested in, and I've always known, it seems like every company or every organization has their own ways to do this. That is, they have their own ways to kind of, summarizing inventory data might be fairly simple. There might be different ways to calculate the volume, depending on what equation one uses. But then to get to the weight of that tree or the biomass of that tree is very, very mixed. And so different companies use different ratios that convert things like the number of cords per acre in a stand to the number of, the amount of biomass or the amount of, ultimately, again, carbon in a stand. And so these volume weight to conversions are really popular. They're often very simple. They take into account things like the specific gravity of the wood. That is, what does the wood weigh when it's oven dried? What about the amount of bark volume? We often think about the wood is what we're really interested in, but the volume of the bark in a tree can be as much as 20% of the whole volume of the tree. And so if we didn't include that, then we could be potentially underestimating the total, the weight of that bark volume. And then obviously different woods have different moisture contents, and so we need to take that into account as well. And some of those moisture contents differ from the wood and the bark. And so there's some things that we might need to do to take into account those differences. And so I actually rely a lot on in the past I've relied a lot on some data sets that are by these specific companies and organizations. One from a consultant here in the Northeast that has published a small set of some of the common species in the area. I know many state agencies have their own lists of these conversions from volume to weight. The state of Maine has one that's always included in their stumpage reports. And so really interested to kind of look at those. But there's no real consistent way, if you're working across a large region or across multiple species, to understand and to calculate the volume to weight conversion. And so I recently did this with pretty much all the species in the U.S. And so if you look on the U.S. Forest Service's Forest Inventory and Analysis database page, one of the most important data sets that they have is what they call the species reference table. And so in that table is basically every species that's found in the National Forest Inventory for the United States, and some key information about those species. So it contains things like the specific gravity of the wood, which equations do they use when calculating this or that, whether it's volume or biomass. They have the lookup tables, so you can link, say, a species code that's found in that table with a species, if you have another table that contains some additional information that you might be interested in understanding. And so with that species reference table and all the information that's really provided in it, things like the green volume and oven dry weight, the specific gravity, the moisture content, really kind of took a look at all of those, and for each of those species came up with a volume to weight conversion factor. And so these volume to weight conversion factors are basically based on two things. If you measure the amount of cords on a per acre basis, and so oftentimes, I always think of the easy conversion of, if you see a log truck going down the road, pretty typical log truck, and it's got pulpwood on it, there's about 13 cords of pulpwood on that log truck. And so you can imagine, trying to convert that to say, what's the weight of that? And so you can easily do that with some of these conversions. And so I'll share a link to the post where I've done this and the data set that you are more than welcome to use. And so as an example with sugar maple, if you kind of take into account the different wood properties of sugar maple is obviously a more heavy, more dense wood than some of the other hardwoods. And so calculating that, get a green tons per cord. And so if you measured, say, sugar maple pulpwood on a per acre basis, you would multiply the number of cords you found on that acre by 2.94. And that would give you the amount of green tons that are found in that acre of sugar maple pulpwood. And so, as you might suspect, I've done this for that large data set of over 2,500 different tree species. I've got a graph in the post about this that shows, obviously, conifers. They're also called softwoods. They have a much lower cord to green ton conversion than some of the hardwoods. And so you can kind of see and compare perhaps what you've used in the past for some of these conversions to what comes up with using the FIA data approach like I've outlined. And really interested to see kind of those different volume to weight conversions for all of those different species that are out there. And so again, I really encourage you to have a look at these. Really, it'd be interesting to hear, if you end up using these, how they compare to what you've used in the past or what you've seen in the past. There's a couple of other publications out there. I know the Forest Service's Southern Research Station has a great publication about converting between not only just volume to mass conversions, but also separating that out by different product classes. So whether it's pulpwood or pole timber or softwood or saw logs. So they've got some different approaches in one of their publications that look at that. And again, lots of localized folks use different conversion factors. So companies, even in different areas or different regions that they're working in, will have some of these different weight conversions. And so really interested to see kind of how they might compare to what you're using. I've done that a little bit with some of the species common here to where I sit in Maine, with some of the values that the Maine Forest Service provides, and found some pretty similar estimates. And so know that they're kind of in line with what's already being used out there to convert the volume of a tree or different product classes to the amount of biomass or carbon. And so I hope this is valuable to you. I'd love to hear if you've used these or if you plan to kind of change up how you're using them, if you make any use of these different conversions that I provided here. I'd love to hear from you. Thank you. Thanks for listening to the Forest Analytics Landing Podcast. For more information on how data and analytics can empower your organization, visit arbor-analytics.com.